Okay, we're given a function here, f of x equals 2x cubed, take 3x squared, take 12x plus 27. We're given a domain for x between minus 3 and 3 inclusive, and we had to find the minimum and maximum values in that domain. Okay, so we've got a cubic function here. I'm going to draw a very rough sketch. I have no idea what this cubic's going to look like, but let's say it looks something like that. And we're given this domain, so we're given from minus 3 to 3. So don't judge too much about whether the minus 3 comes before this bump or not. I'm just trying to have some idea of what this diagram might look like. So we have to find the minimum and maximum values. So there's actually, normally to find the minimum and max of a function, what you do is you find where the tangent is 0, so where it's flat. So that's the point of inflection, and it's a turning point there, and that's when the first derivative equals 0. So that's a potential maximum. This is a potential minimum. Could be the other way around if the function looks different. But also we need to check the endpoints, because there's an endpoint there, and there's an endpoint. Let's say this endpoint is here. It could turn out that this endpoint is higher than this maximum. So there are 4 things we need to look at. We need to find these 4 points here. 1, 2, 3, and 4. And then find the max and the minimum y value from those points. Okay, I shouldn't have numbered them 1, 2, 3, 4 because we're actually going to do them. Let's do the easy ones first. So the endpoints are the easy ones. So we'll just do minus 3 and 3. Just substitute minus 3 into the function. So 2 times minus 3 cubed, minus 3 times minus 3 squared, minus 12 times minus 3 plus 27. So minus 3 cubed is minus 27 times 2, so put minus 54 minus 27 plus 36 plus 27. Those 27s conveniently cancel out and gives us minus 18. So that point is minus 3 minus 18. Okay, then let's do the same for 3 at the other end of the domain. So in this case it's 2 times 3 cubed minus 3 times 3 squared minus 12 times 3 plus 27, which is, so the numbers were the same, 54, but positive this time, minus 27, that stays the same, minus 36 plus 27, again these conveniently cancel out, and we get 18, so this point is 3, 18. Okay, so those are the 2 endpoints. Now we look at the one that's more interesting, which is where we've got these turning points of the function. So we take the derivative of that function, and what have we got? So we've got 2x cubed, so the derivative of that is 6x squared. We've got minus 3x squared, the derivative of that is minus 6x. We've got minus 12x, so that's minus 12. And we've got 27, derivative of that is 0. Okay, so 6 times, we can take the 6 outside, and we can find factors for that. X minus 2, x plus 1. That's right, minus 2x plus 1x is minus x. Yep, that's it. And so that's equal to 0 when x equals 2 or minus 1. Okay, so the value of x is 2 or minus 1. That's when the function is equal to 0. So what are the function values at 2 and minus 1? Well, the function value at 2, just substitute that back in, 2 times 2 cubed, minus 3 times 2 squared, minus 12 times 2 plus 27. 2 cubed is 8 times 2 is 16, minus 12, minus 24 plus 27. Okay, what have we got here? 16 minus 12 is 4, minus 20 is minus 20, plus 27 is plus 7. So we've got a point here which is 2, 7. Let's do the same for minus 1. 2 times minus 1 cubed, minus 3 times minus 1 squared, minus 12 times minus 1 plus 27. That's minus 2, minus 3, plus 12, plus 27. Minus 2 minus 3 is minus 5, plus 12 is 7, plus 27 is 34. So that point is minus 1, 34. All right, so what have we got? This point here, minus 3, minus 18. This point here, 3, 18. This point here, 2, 7. and this point here, which is minus 134. Okay, which is the lowest number? Minus 18, 18, 7, or 34. This one is the lowest. Therefore, that one is the min. Which is the highest number? 34 is the highest. So that one is the max.